I'm Aiden Stalker. I'm an application engineer in the Mobile On-Highway group, and I primarily design bearings into axle centers and wheel ends for our automotive customers. The bearing tolerance tool is a resource for you to access Timken's database of bearing tolerances. This will help you make sure that everything fits properly in your application.
Once in the bearing tolerances tool, you're able to enter your part number and display the tolerances for a specific part. But if you're not familiar with how bearing tolerances work, it'd be a good idea to check out the help guide before you watch further in this video. The help guide has some helpful clarifications on what's a standard bearing class tolerance nomenclature and what's precision bearing class. That way, when you're selecting your tolerances in this tool, you'll be able to identify which one is most applicable for your application. Back to the bearing tolerances tool, all you need to do is you need to enter in your part number. For this example, I'll be using 32012X, and I want to see this in metric. So I'm going to look up this one, and then it gives me options of what bearing class I want. So this is the precision level to which a bearing is manufactured. Like I showed you on the prior page, the bearing class can range from K through A for this part. This is in standard ISO part, and it has this metric tolerance structure to it. So K or N are the most standard, and then C, B, and A are all precision class. For this example, let's look at K first, and then click Calculate. Now down here, you can see all of the nominal dimensions for this bearing, and then you can see the tolerance results. We have cone bore, cone stand, cup OD, cup stand, overall width, and radial runout. And these will give you an idea of what the tolerance looks like. For this ISO part, we have for both the cone bore and the cup OD, we have a +0 minus tolerance. So this is a minus 15 micron because we're in metric units here. Now say we want to see this in imperial. This is an ISO part, so it won't work quite as well, but we can see what that would be in imperial units and the tolerances in inches as well. Before we move on to another part number, let's see what this looks like for class N. So for class N, we'll hit calculate, and you'll come down here and see these tolerances haven't changed all that much from class K. Maybe they haven't at all. Let's check between the two. What you see here between class K is that the cone bore tolerance and the cup OD haven't changed, but I believe the cone stand is different between class K and class N for this part number. That's correct. We see here for the class N, for the X32012X cone, we see that the cone stand is dropped from 100 micron to 50 micron when you switch between bearing class K and N, N being the more precise of the two. Let's try this with a different part number. Let's do the LM603049. We can select any standard assembly of that cone. And now we have 4230 and 00 bearing class structure here. You can see from the help guide that these correlate to, for the metric system, the K and N correlate in the ABMA inch system from 4 to 2. So because we have an ABMA part here, the LM603049, we're given the option of bearing class 4 and 2 as our standard class. When we go to look at these results, we can see these in metric, or since this is an ABMA part, we can switch over to inches if that's more relevant for us. And one thing to note is that these tolerances work slightly different for the ABMA parts. You have the -0 plus a value. So in this case, it's plus 0.0005, half a thou on the cone bore. Let's look at one more part. Let's do a CRB this time, and rather than enter the full part number, let's look at just using the wildcard option. So I'm just going to select this first one because the CRB doesn't matter to me too much for this example. And then we see, once again, we have a different precision class system here. So for reference, this precision class, we're using the RBEC, and we have 5, 7, and 9 for this cylindrical ABMA part. However, this, for the ABMA part, the ISO part has P0, P6, P5, 4, and 2. So for this CRB, you're able to choose your standard class that you would like. For this one, we'll choose P0, and we'll calculate the tolerances. Down here, we can see what those tolerance values are for each of those important characteristics.
Thank you for watching this demo today. To access this tool, go to engineering.timken.com.